Hello everyone, for this tutorial video I would like to explain why pressure decreases in a faster moving fluid, even though this may seem not to make sense based on our day-to-day experience. A physical explanation of why this is so could be that, since we remember from the previous tutorial video that the volume flow rate must be constant, this means that for the volume to be the same while it is moving faster, the molecules must spread out more. As for it to be the same volume in a narrower channel, the length must increase as the area decreases by definition of the channel being narrower, which is what was shown explicitly in the last tutorial video. You can see for yourself that this is true by holding a piece of paper in a slack manner such as this, and then blowing over the top of it. The narrower pressure caused by the high velocity from your blow made the paper want to move in that direction, as the pressure was the same where you were not blowing. So the pressure that was normally equal was now higher as you create a lower pressure region. And owing to the smaller mass of the paper, it did not take a lot of pressure for it to move. Mathematically, this is stated with Bournelli's equation, which is absolute pressure at point 1 plus 1/2 density times velocity squared at point 1 plus density times gravitational acceleration times height at point 1 is the same throughout the whole fluid. I.e., if the velocity decreases, the pressure must increase, and if the pressure decreases, the velocity must increase. This is known as the Bournelli equation, after the physicist who first wrote this down, Daniel Bournelli. Other common applications of this principle are in perfume and spray bottles. So for example, when you squeeze the nozzle, the lower pressure flow from the gas will draw the liquid toward the gas, and then these two flows will combine to create a fine mist. Airplanes and sailship sails also create a higher speed and therefore a lower pressure, but they do this in a different way than the other objects that were studied. With those types of objects, you will see if you look closely that one end is longer than the other, so the air will want to flow faster over the longer end. And because the flow is faster, the pressure is lesser, and so the greater pressure on the other side pushes it in the opposite direction. However, the caveats to these types of scenarios are that A, this only works if you do not account for friction, and that B, the flow is only in straight line paths, which although the most convenient to study, is not always true to real life. In the next tutorial video, we will study factors that affect resistance to flow, including friction between the fluid and its container, and inside the fluid itself. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.